Today we're talking all about lifting a robot up and off the ground and how you might want to do that with one of these small telescopic elevators. We have about 46 centimeters of clearance to the bottom of my robot, which 46 centimeters actually does get you a full clearance point with another robot off. I'm Coach Pratt, and I've been teaching robotics and design for over a decade now, and I've mentored FTC teams to winning national championships. And today I've got a couple of Offset's new kits here. This is the nano telescopic lift, and we're going to run this thing through its paces today. We're going to see just how much weight it's capable of lifting. We'll take a look at some basic stats, compare it to some of the other lifting mechanisms on the market, like some Masumi slides or other linear slide systems that exist. We'll run through some empirical tests to see how much weight and how quickly it can lift those things. And then I'll also share my thoughts about whether I think that this is actually a good product or not to be using on your robot for the FTC DECODE season. This is the Offset Robotics nano telescopic elevator, telescopic lift, telescopic box tube slides, lots of different ways of calling this, but it's a pretty impressive little piece of kit. At full retraction, this thing sits at about 31.5 centimeters by about 10 centimeters. No, about 9.5. If you were to reduce the size of the length of these, you could also have this thing down, subtract about 3. You could have it down to about 6.5 centimeters across that axis. And then across this axis, it is about 7 centimeters. So it's about 7 by 7 by 31. So pretty impressive, small little piece of kit. Now, full disclosure, the Offset guys did send me 2 of these kits to build a review, but as always, my views are always my own. And I try my best to give you guys my honest opinion on these things. The nice thing about this is you can drive it with a servo. Now, on their setup here, there is a coupler from a 25-tooth spline right over to an 8mm hex shaft. I've had to use a standard coupler here because I don't have one of those, but you could reduce the length of these in a bit to make this quite a bit smaller as well. This new kit comes with a nice little mounting plate up on the top with some M3 screws. It has mounting plates up on the top and in on the sides as well. And in my experience, has been pretty robust and rigid. Now, I believe that the top 2 stages of this slide are made out of 6000 series aluminum, whereas the final stage is made out of 7000 grade, just to make things a little bit more rigid. And I believe that all of these anodized black plates are also made out of 7000 grade, but I could be incorrect on that one as well. I'll let you know in the description if I am not correct on that. Now, as far as max extension, this little guy's got a max extension length of, let's pull her out here. We'll say it's a max stable extension length. The stroke length is about 49 centimeters with a total length of 78.5. Now, let's see, how does this system compare to other systems on the market in terms of weight? I'm not going to bother comparing this system to other systems on the market in terms of stroke length because, at least for this, stroke length is not 100% necessary. So let's grab out a little scale. I'm also going to measure this with the motors on because I think that's an important note. So the total weight of the Offset kit sets us up at about 530 grams. Not about, at 530 grams. We'll take a look. I've got a Swift Slides here V2 version. It's only got 2 stages on it set up in the 250mm length, as well as a full gearbox from Rev. So this is something to think about. So we'll take a look at the total weight of this system, including the motor cables. Let's see if I can't get this thing to actually stand up. You're looking at about 1,077 grams, so about twice the weight of the Offset. And then I also have my own kit here, which is, of course, my standard design for the Masumi SAR 330 slides. So I'm going to take these, and because my mounting hardware is a little bit longer on this system, I'm also going to less the weight of 2 of these extensions, and then also less the weight of 1 of these so we can get a more accurate result here. So looking at 1483 minus the weight of 1 Masumi slide, which is 200, minus weight of 2 of these. These things are 85 grams, so that's 170 grams. So in total, you're looking at about 1,113-ish grams for my system here. So by far, the Offset Nanolift is definitely the lightest lift. It's also the only lift that drives this thing by a servo. But that's not the only thing that matters with a kit like this. So let's take a look at our testing setup here to see how much this thing can lift and how fast it's able to lift up a robot as well. So let's talk really quick about my testing setup here. I've got 2 of the nano lifts set up in the middle of my robot, and these just sit down onto a large flat plate. On the bottom of my flat plate, I simply have these little bracketed arms to be able to help with a little bit of sideways stability, and I'm using 8mm plywood for this. If you were to run this on your robot, I suggest you use something like aluminum, and you might want to back set this off on your robot a little bit so that it's not quite directly in the middle. You might want to back set it off a wee bit to be able to give yourself a little bit of extra space on the robot to fit in, but it should work for our purposes just to see how quickly this thing's able to lift up. I'm running on 2 Gobuilda torque servos. I may run these on speed servos just to see how much those things would be able to lift up on this. And as far as the actual lifting methodology, I have 1 kilogram and 500 gram weights that we can move up and down in so we can see if we're able to lift ourselves up and down. We'll start with just some base tests for how quickly does this go with no load, how quickly is or how heavy is this robot in general. And then we'll move on to start doing some loaded tests just to see how long it takes for this thing to get up and down, whether it's realistic to use this on a decently heavy robot to be able to lift up with a servo with such a small amount of form factor. Now, in terms of my testing setup here, I've got a super basic setup. I'm literally just holding the B button to go up, holding the A button to go down. I don't have any encoders in this. You should probably have some sort of encoder if you're going to lift this thing up. But the first thing to check is this thing capable of lifting up our base robot, which is 7 kilograms, to our maximum height of 38 inches or 96.5 centimeters. So that is from the bottom of our plate to the top. Presently, if we were to look at the height of our robot, this robot sits at about 34 centimeters, which is well within the, I believe it's 45.7 centimeters that you're allowed to actually run these things at. So you still have a lot of wiggle room if you were to sit these things up inside of one of your robots at its full reduction point. So let's run a quick test here. We'll see how long it takes for us to get up to actual height. And I'll put that timer up on the screen for the minute that I actually start pushing the B button to how long that actually goes. And we need to get up to a total height of 96.5 centimeters. So we'll see if this thing is capable of even getting to the top of our robot point here. And we'll start our lift in 3, 2, 1, go. This looks like it's starting to get pretty close to maximum extension. I don't want to go beyond because you start to lose some rigidity here. Oh, I can see on the other side. And we're going to call that maximum extension. So your maximum extension here is actually about 79.5 centimeters before you're going to start running into issues. We have about 47 centimeters. Oh, actually, I should go to the bottom of the wheel. And at the bottom of the wheel, we have about 46 centimeters of clearance to the bottom of my robot. Which 46 centimeters actually does get you a full clearance point with another robot off. Oh, actually at 46 centimeters minus my 8 centimeter plate. But if you were to use a thinner plate, you would be able to get yourself up with another robot underneath you a little bit better. So I'd recommend you use a 3mm or a 4mm plate of something of a really rigid material. But that does get you within that 45.37 centimeters or the 18 inches. So another robot could definitely fit underneath you. As you are lifted up, that other robot would also set on top of your plate, and that would also run in. Let's lift ourselves up here again, and let's just see how stable these things are. Now, the stability is going to matter a bit based on how much weight you have on your robot, as well as how much lateral stability you have from another robot coming in. And I don't have a lot of stability added in on this, but overall, actually, I will do these quick tests first to show you. So we're able to lift ourselves off because I have such a fat plate. It's like not going to come up. I'll give this a rotation 90 degrees so you can see the other way of its lateral stability. And I'm actually starting to flip off of my plate here. But I think of another robot to drive on, that would probably be stable enough to not have to be concerned about a part coming down on you. Because I think speed on this final part is also going to be a consideration for teams. If it takes you too long to be able to do a double park, the additional 20 points versus being able to shoot in more balls or more artifacts might also not be worth it in that respect as well. So we'll do a little bit of analysis on this after, because I actually don't know how long that took. So now let's start doing some weight tests. So right now this base robot is 7 kilograms. Let's load on 1 kilogram. We'll go up to 8 kilograms and we'll see if we're still able to get up to full extension, as well as how long it takes to get there. So we'll get started in 3, 2, 1, go. Looks like 8 kilograms is basically, this thing's not even going to feel it. Still the amount of same. You could definitely lift up an 8 kilogram robot with a couple torque servos, no problems. Let's put another kilogram on here. We'll go up to 9 kilograms. I'm going to try my best to load this robot somewhat evenly as time goes by. So now up to 9 kilograms. Let's do this test in 3, 2, 1, go. And that's full extension at 9. Still no issues there. Starting to get a little bit of forward lean. And let's go up to 10 kilograms now. And that's full extension at 10. So 10 kilograms is still really solid. Let's go up to 11 and see where that takes us. So perhaps rather surprisingly, we're still going just fine. Let's go up to 12 kilograms. My platform's starting to run out of space here. It's really starting to feel it at 12 kilograms. We may get 13 out of this system. We may not get 13 out of this system. Let's try it out and take a look. Whoa. I'm going to say you're probably going to max out about 13 kilograms on this system. It looks like 13 probably going to be our max. Could you get a little bit more if you were to use a servo power hub, something like a 6-volt power hub as opposed to a 5-volt? Probably. If you were to use a slightly torqueier servo than these current servos, you could also probably push out maybe 14, maybe max out at about 15 kilograms. But I think you can start running into some speed limits there as well. Now let's go take a look at some of the data and then talk about whether this might be a good solution for your team or not this season. So let's talk about final thoughts and what do I think about the Offset Robotics and who do I think this is for? In my opinion, this is really for experienced teams. If you're a rookie team, I highly suggest that you don't go with this product. And we'll talk a little bit what I like first. So what I like about it, it's really small. It's really light. It's about half the weight of some different typical linear slide designs on the market. I'll throw some numbers up on the screen here as to how much a servo weighs versus how much a standard DC motor weighs, as well as looking at the total weights of the system when we factor in the fact that we take the motors off, just the systems themselves, the weight of the system reduces quite a bit because those DC motors are really, really heavy systems. Now, this is definitely for a team who's looking for something a lot smaller or a lot more compact because you are going to fit in a lot more compact on multiple axes to be able to fit a servo in comparatively to a different design. We can see if we were to overlay them on top of each other, you're ending up with quite a bit of space savings. Well, not quite a bit, about a centimeter on both axes, which is not bad. I think it's a pretty impressive. This thing can lift up to about 13, realistically a 14 kilogram robot. It's probably about the max that I would do. Unless I were driving this thing on a servo hub, then I'd probably run a little bit more. But when we consider the fact how long it takes this thing to be able to lift itself up, you really got to factor in is a lift worth it for the amount of time that it would take for me to get in? Look at how long does it take, and provided you can get a light enough robot, I definitely think it's worth it for your team strategy if you can get that weight down, because weight is so critical to make this thing be able to lift itself up and down in a reasonable period of time. Now, some things that I don't really like about it, I'm not a big fan of the fact that it's string driven. In this season, you technically only need an extension string. You do not need a retraction string. It is not easy to tension these things. And the fact that this is a significantly smaller unit means that it's even harder to tension this than the typical elevator from Offset. I've talked about this before, especially when I'm doing my stringing. You can definitely do it, and you can see that mine doesn't have enough tension on here, which is why I was occasionally slipping on the back of my slides here. What I do like is that they are constantly improving this thing. So I've given a decent chunk of feedback to these guys, and they are continuously improving these kits. So I think it's really well machined. I think, granted that you know that this thing is not easy to assemble, if you are competent at assembling these things, even someone like myself, I consider myself pretty competent doing this, and I still had quite a pain trying to get this thing properly tensioned. If you'd like to get this kit and you think that it is a good fit for your team, considering that your robot is light enough, and you think this will fit in as a nice package for your robot, you can use my link in the description down below, as well as the code CoachBrat5 to get yourself 5% off on this. It helps you out, and it also helps me out a little bit as well to be able to continue to make tutorials like these for you. If you got any questions or comments about my testing methodology, let me know in the comments down below. If you're looking for more CAD resources and how you might use this in a different lift design, I've also got some CAD available on my robotics community. And as always, best of luck out there this robotics season.